how you can set up your own business. Build a RAS fish farm for sturgeon in a field where there is absolutely nothing. There are 20 fish holding tanks like this. Just such small suburban agricultural plots are very suitable for fish farming. Such a vast expanse, there is practically nothing around. What does it take to turn a piece of land where there is nothing but grass into a fully functional fish farm as you see it now? Come on, I will show you everything. Hello everyone, my name is Anton Pelcher. I'm an engineer and I've been building fish farms for over 10 years. Today we're going to see a very interesting facility. I will tell you how you can set up your own business. Build a RAS fish farm for sturgeon in a field where there is absolutely nothing. So here we go. We will get to the farm and I'll show you everything in details. You're probably wondering where we are now. Of course, I'll show you. This location is called Ulmo, and it's about 10-15 kilometers away from Chisinau. So today we're in Moldova. So I have a site here, approximately 20 kilometers from the city. And what should I do with it? Probably set up a production facility there. Well, it's possible, but first of all, it's agricultural land. Build some kind of a hotel or restaurant. Then it would be something extraordinary, so that people would be attracted here. That is the question of feasibility. To grow there some vegetable crops or use it for a vineyard. And you know that there are lots of vineyards in Moldova. It's also possible, but the area of the land is very small. 3 to 4 hectares are not enough to organize an efficient business and grow agricultural crops. And in principle, just such small suburban agricultural plots are very suitable for fish farming, especially in RAS, because they are quite compact. What is farmed there? In general, it's a traditional fish species grown in RAS, sturgeon. It's grown up to grow out weight. But in fact, farming grow-out sturgeon is, so to say, put on the back burner, as the primary focus now is farming sturgeon for caviar. That's why this farm is oriented exactly on sturgeon farming for caviar, and I will show you what it looks like in general. This farm is located in the countryside, on the outskirts of this village. As you can see, there is such a vast expanse, there is practically nothing around. The land area is about 4 hectares. Initially it was agricultural land, but according to the permitted use, it was land for pasture, meaning that it was agricultural land, but for pasture only, and a fish farm could not be built on it. So Toda, the owner of this farm, had to re-register this land through the local administration and to change the purpose of the land into agricultural production. This is why now everything is fine according to the documents. 4 hectares, and as you see, the building 12.5 by 80. And then there is a new construction that's going on right next to the existing farm. So let's start with talking about what it took to transform an empty site, where just grass was growing, into a full-fledged fish farm as you see it now. And we will start with the electricity. Probably you won't be able to even start the construction of the building if there is no electricity on the site. So the first thing Tudor had to do was putting up a transformer station and bring in electricity, which will supply the existing building and so that there will be enough electric power for future farms as well. Those who are already knowledgeable in the field of RAS fish farming know that the temperature on the farm should be the same all year round, so in order to maintain the same temperature heating is needed, and also gas. And with gas it was such a complicated story, and it was solved, so to say, by sweat of Tudor's brow. Well, everyone probably knows that it's not easy to get gas, but here it was connected. The whole process took about half a year, but now they have gas. In addition to heating, the fish needs water. A borehole was drilled here. This farm is supplied with water from a borehole, which is located inside the building. It supplies about 7 cubic meters per hour. Basically, it's enough to completely supply this building with clean, fresh water. And of course, if we feed 7 cubic meters of water to the farm, we need to drain it somewhere. So in addition to the infrastructure of the site, we can add these ponds, which were dug specially to discharge and treat wastewater there. In fact, these are bioponds. Plants are growing there, and they consume nitrates, suspended matter. They were dug on the principle of cascade. So you can see another pond over there. After being deposited here for about a month in these ponds, the water is completely treated and purified and can be discharged anywhere further on the terrain or is being filtered by the soil. And guess what we're going to start with? Actually, the office. This is where all the most important people on this farm gather, and this is the owner's place. By the way, his name is Tudor. He lives here in this village, and it's his native village, and he decided to set up a sturgeon farming business here. In fact, he has several different business lines, but I will tell you about one, probably the most interesting, apart from the sturgeon farm. The thing is that they make clothes by order of a very famous Italian brand, but I'm not allowed to name this brand now. It wouldn't be correct, but they are one of the main contractors of this brand. Just imagine a well-known, expensive Italian brand, and the clothes is sewn in Moldova. Actually, this is all official. They provide for a very high quality. Tudor even gave me a couple of things. So if you see me in some expensive clothes, you know it's definitely produced here. This sturgeon farm was initially a hobby for him. He started growing sturgeons in concrete tanks, experimenting, but his first batch without understanding what kind of fish it was, and it turned out that they survived. He became more interested and involved, and so he gradually improved the farm, and that's what he finally got. A couple of years ago he decided to get serious about it, build this farm. In fact, it is still experimental. And he is also in the process of construction of another farm now, which will be a large-scale industrial farm. So he is experimenting a lot, fortunately with us. So come on, I will show you everything in more detail. When I first came to this farm, the building had already been built, the tanks had been installed, even some of the technological equipment had been purchased. And that was where our acquaintance started, as we needed to help bringing this farm to a good result. Before I show you the technological equipment itself, let me say a couple of words about the building. The area of the building is about 1000 square meters, and to be precise, it's 13 by 80. So 1040 square meters is the area of the whole farm building. As you see, it's a sandwich panel building, which means there is a metal bearing structure and the sandwich itself, which is the insulation. The roof of the hangar is gable. Ceiling height is around 2.5 meters, and at the ridge it's about 5 meters. And now let's talk about this farm, about the system itself. There are 20 tanks like that, each about 5.70 in diameter and 1.20 in height, about 25 cubic meters in volume, so the total volume of fish holding tanks is 500 cubic meters. That is 500 cubic meters of water only in the tanks, not including the water treatment system. Each department had the water exchange capacity of about 300 cubic meters per hour. It's a little bit more than one water exchange. This farm is designed to farm sturgeon for caviar. The estimated maximum capacity of the farm is about 1 ton per year. It's clear that the brood stock has not been formed yet, as the farm has not yet been operating for a long time. So of course we're not yet talking about getting caviar. The process is at the beginning. Generally speaking, RAS at this particular farm is split into 2 blocks. There are 10 tanks in each of them, each tank with the volume of 25 cubic meters. There's 250 cubic meters in each line. Each line is independent. They're not in contact with each other. Here you can see RAS piping, meaning pipes running from the tanks to the drum filter buried under concrete. How was it done? First, a concrete strip was poured, it's so-called strip footing. Then the building was erected and concrete floors were not poured. We laid all pipes beforehand. Then the pad was provided for, and only after that concrete was poured. So everything looks beautiful here. Nothing is sticking out. All RAS pipes are laid. And by the way, I need to mention this pipe. It's 300 diameter pipe and it's connected to 2 drum filters. Now in fact there is only one connected here, because some of the pumps are not in operation. There is simply no such need, to fear fish. That's water gets to the drum filter. Those who watch our channel know exactly what it is. The drum filter treats the water from mechanical suspended solids, all feces, residues of uneaten food, all that is trapped on the drum filter mesh. Periodically flushing is triggered. High-pressure nozzles supply water to the drum, clean it, and mechanically treated water comes out of the drum filter completely clean of various fecal matter. The drum filter mesh is 60 microns. After the drum filter, water is collected in the pump pit. Here it is buried in the concrete below zero level, right under the drum filter. And from the concrete pit these pumps, there are 3 of them, take the water and supply to the biofilters. 2 pumps are operating, another 2 are standby ones. These are Italian Pedrolo pumps. Each pump gives 150 cubic meters per hour, which means that total water exchange is 300 cubic meters per hour. This is slightly more than 1 water exchange, and that is more than enough for the whole sturgeon broodstock. So, through 2 110 mm pipelines, the pumps pump water upwards to these biofilters. These are 2 plastic biofilters filled with media, 1,500 square meters of media per cubic meter. These biofilters treat water from dissolved impurities, that's nitrogen. To be precise, 2 groups of bacteria first convert nitrogen into nitrate NO2 and then into nitrate NO3. NO3 is flushed out of the system. So basically, this is how we get semi-biological treatment. Each of these biofilters contains about 3 cubic meters of media to ensure that the media is constantly being babotouched. The media is moving, air pipes are connected to the biofilter, which are in its turn connected to air blowers. So these are compressors which continuously, 24 hours a day, supply air to make the media move. After the biofilters, the water is fed to this oxygenator. About 50% of the flow is through it. It's a low-pressure oxygenator, jet type. It saturates the water with oxygen so that it's enough for fish to live and grow. Where does the oxygen come from to supply this oxygenator? So, for this purpose, we have this unit called oxygen concentrator. It has the capacity of about 40 liters per minute. It fits pure technical oxygen, 93–95%, which is further dissolved in oxygenator and supplied to fish already dissolved. Well, and a parallel independent circuit is ozonation system, though this system is not yet connected. It consists of 2 main units. An ozone retention tank, which water is fed to and then gets in contact with ozone, and an ozone generator that produces ozone. An oxygen concentrator is connected to ozone generator. Pure oxygen is fed to the ozonator, a high-pressure discharge oxygen is transformed into ozone, and ultimately ozone is fed to the ozone retention tank. Why is this needed? It's very simple. Ozone is the strongest oxidizing agent. It provides for both disinfection and water treatment. As this system is not yet connected, the water is a little bit muddy, but there is nothing wrong with it. Very soon this system will be connected and in operation, and I will be able to show you absolutely transparent water. After biofilter and oxygenator, the completely treated water is supplied to fish holding tanks through this 200 mm pipe. So the fish is held in fully purified, oxygenated water where it has optimum growth rate. And of course, RAS equipment cannot operate perfectly without control unit. This is our farm bridge, one for each RAS department. It controls all the equipment: pumps, blowers, oxygen concentrators, ozonators, in general all RAS equipment. And from this panel it shows alarm signals. It can automatically switch the equipment from operating to reserve units, so it controls the operation of the entire technological line.
And now let's consider stocking materials and stuff.
Let's start with the fact that naturally any fish needs feed. This farm uses feed produced by Coppens, a Dutch company, and this feed has already been purchased and it's now been stored. As they are still forming broodstock to get fertilized eggs later on, they absolutely need to use special feed for broodstock. Feed is purchased approximately every 2-3 months, so that on the one hand it's not wasted, and on the other hand they don't have to buy it too often and spend too much money on logistics. Stocking material for this farm is delivered at the stage of fry as there is no incubation block yet, so they have to buy on-ground fry. For a farm focused on getting fertilized eggs, it's enough to buy fry once a year, well, maximum 2. Ordering fry more often is not really needed. The fry is mostly imported here from the Ukraine, because it's a little bit more difficult to buy sturgeon fry in Moldova. Let's talk about grow-out fish sales. To be honest, since this is a so-called pilot project and the broodstock is just starting to form, it's a little early to engage in sales, so at the moment the broodstock is only accumulating here. But nevertheless, I will tell you about how sturgeon caviar sales are handled in principle. First of all, you get the final product in the form of sturgeon caviar, and it can be sold as raw caviar or ready-to-eat caviar, which is ultimate food product. What is the difference? The second option is a food product packed in cans and with the enclosed declaration of conformity, which means that it costs more and can be sold as a final food product. Raw caviar is cheaper because it's a semi-finished product. The average cost of farming sturgeon for caviar is about $200 per kilogram of finished product. And of course, the cost of sale can vary. The average wholesale price is around $500 and the retail price makes $700–800. In order to calculate the economics that this firm can provide, in principle, you shouldn't make any complicated calculations or apply elaborate coefficients. The farm capacity is a ton of caviar per year. There is a primary cost. There is an approximate average sales price. So you can easily calculate how much you can earn from this farm at optimum capacity. And now let's move further to the building engineering systems. There is gas as I have shown you earlier, so it's connected directly to these two boilers. Each of them has the capacity of 50 kilowatts. So in principle, for the whole 1000 square meters farm and taking into account air and water heating, we need about 100 kilowatts of power. That is the maximum capacity of the boilers. Naturally, the entire automation system is already completed here. And furthermore, the heating is connected to the fan heaters. The heating of the farm from the boiler is now connected to 6 fan heaters, which are distributed throughout the whole building area. The fan heaters in general are very efficient, and if you go on watching this video, you will actually see them on the background. Fan heaters are the same radiators, but they have an additional temperature sensor, air sensor, and a fan that blows air around the room. Imagine the temperature inside a building drops dramatically. The heaters turn on and fan hot air around facility and then turn off. So unlike common radiators, they maintain the temperature in the building automatically, and in addition they don't occupy a lot of space and a huge amount of piping. The lighting, as you can see, is one line at the ridge. And we have a very good distribution of light across the entire building. Water supply. There is a borehole drilled inside the building, which has the depth of about 7 cubic meters per hour, and that is enough for the whole building. Sewage. I have shown it earlier. The sewage pipes are under the concrete. and the wastewater is discharged directly to the cascading bioponds. Well, that's probably it. But I have prepared for you a special bonus that you can download following the link in the description to this video. That is the calculation of the farm with the capacity of 1 ton of sturgeon caviar per year. There you can find the number of tanks, the information on the required water treatment equipment, and generally all the basic calculations of such a farm. It was Anton Pelcher. Hope you liked this video. If you did, press the like button, subscribe to my channel, the channel about how to grow fish and earn good money from it. Bye!